Welcome to the Plasmatreat stand here at SMT Connect. Delighted to be joined by Nico Koenen. Great to see you again, Nico.
Great to see you, Trevor.
Yeah. So you've got, as always, an interesting booth. You've got some nice demonstrations over there showing a plasma system used for the preparation work, but also one for coating as well, and that sort of thing. What sort of coatings and things would you typically put on to?
Well, the coatings is basically it's comparable with a CVD process, but then in open air. So you do a chemical deposition, and basically the characteristics of the coating can be determined by the precursor material that we apply. So we can make something very hydrophilic, hydrophobic, but we can also make a barrier coating or an isolation layer or a protection layer. Or we can say we want to have a better adhesion promoter. So basically replacing primers by a nano coating. So there's many applications within this field, and it's, let's say, a rather new field. So we're getting applications on a daily basis. So it's very exciting to work on those.
Yeah. I mean, you cover a lot of industries and a lot of different technologies, but in fact, we've got some examples in front of us here showing just some of the areas that you're involved in electronics. So let's talk about where these key areas are. Obviously starting off with the PCB and preparation for cleaning. So
it's preparation, typically pre-treatment before conformal coating or before molding. So that is a standard application. Here you see LEDs, basically before they get overmolded or before they get potted, and making sure that there is a good adhesion. This is actually LED light that goes into a swimming pool.
Okay.
So it has to be very
hydrophobic coating too then.
Yep. So it has to be watertight, have good protection and so on against the water, swimming water and so on. So any application basically where you need a very good adhesion or stronger adhesion, plasma is really bringing something forward.
Right. Now, I see you're also moving into the semiconductor world a bit more. So tell us about some of these applications.
Yes, we've had a number of applications within the semiconductor. I think plasma in general is very common in the semiconductor. I mean, you have the traditional applications like wire bonding, die bonding, treatment before underfill. So we're getting in those areas as well with open air, so that people shifting from vacuum to open air, because there's a number of advantage there. I mean, it's typically it's faster. You can build it inside of the line instead of most of the systems are a batch. I mean, there are inline systems available, but still a minimum time that you would need there is 30 seconds, while sometimes we can do something in 5 seconds.
Right.
So there's quite some advantages, but we also have new applications there where we do pre-treatment before thermal compressed bonding. So we treat the surfaces, then there's a flux application, and then there's thermal compressed bonding. And now we go into applications where we are removing oxide layers on top of the solder balls, so that you can have a fluxless connection.
That's really interesting. Yeah, that would give it a much better connection, wouldn't it?
Well, I mean, if there's no flux, then there's no flux residue, and so on. So that will bring the industry a lot of advantages, I would say.
Yeah, absolutely. Yeah, keep that hot, sticky mess away from them. What other areas have you got in here? I see you've got the IGBT application here, PT bond. You've got sensor housings, epoxy bonding. Yeah,
I mean, there's again, plasma can be used in almost anything. So you go from PCB manufacturing to PCB assembly. If we go, let's say, in the power electronics, the IGBT, because that's a upcoming market with all the new things going on, the EV batteries or the EV cars and needs higher power modules and so on. So on the IGBTs, we mainly are doing reduction of oxide layers on copper, and we can do that inline with open air plasma.
Right.
So that is a really major breakthrough that we have done there. Other applications there is, I mean, you have sintering, you have molding, and all these kind of pre-treatment before the next step are playing in there. So in the assembly of an IGBT module, I think there's like 3 or 4 potential plasma steps.
Right, that's incredible. You've also got a number of plasma steps that you're doing for batteries.
Yeah.
For cars. Tell us a little bit about that.
I mean, you have, of course, the different batteries. I mean, you have the cylindrical cells, the Tesla cells, or you have the square ones. We do a number of applications. One application is that we treat the sides of the packs before the dry film or before they get coated. We are doing the treatment of those assembly plates where all the cylindrical cells are wire bonded to.
Right.
I mean, I think there's like 3 or 4 more applications in that field. So again, very important market for us because factories arise on a daily basis.
Right. I don't know how you keep up with it all, to be perfectly honest.
We're struggling. Our lead times are getting a little bit higher, so but we are expanding. So we're going to expand our production capacity. We're hiring people all the time. So
are you going to expand that here in Europe, or are you going to expand, like open new areas maybe in the United States or Asia?
Yeah, I mean, it's on the roadmap and it's on the thinking. Okay, should we also move some production to other areas? For now, we're expanding in Germany. So we have still quite some area available. So that's going to be the first step, and then we'll have to see how things evolve. But of course, people have been thinking about, okay, if a lot of the end products are going to Asia, would it make sense to do like partially assembly or over there?
Right. Well, it's a fast-changing market. I mean, everybody's talking about more regionalization, so it might make sense that you consider that too.
Yeah, we have seen that the world has a little bit changed, I think, with COVID and everything. And if you look at now, Shanghai is closed.
I know. Exactly.
I mean, our local guys have said, don't bother shipping anything because it's not getting any to us anyway.
Right.
So so maybe local manufacturing or local availability of tools. I think that's something I think other people might look into as well, because it might be more important in the future.
Are you suffering any supply chain issues?
Yeah, we do. I mean, in the beginning, we had quite a large stock of the critical components, so we did a good job there. But here and there you see some, and these can be small things like a clamp or I mean, really, but you need them, right?
You need them,
And so, it's a challenge to make sure that these small things don't delay full shipment of a complete tool.
Yeah, absolutely. Yeah. Well, it's always great to catch up with you, Nico. I want to thank you for showing us some of the unique applications you've got for Plasmatreat, and we'll hope that you can keep up with the blistering pace of
We'll do our best, and I'm really happy to see some people again after a couple of years, so
I know.
really enjoying being at the show, right?
Good. All right, thank you for coming in and joining us today.
Yeah, thank you.
Electronics are part of our world, expanding by application to open up new opportunities for automotive, healthcare, and many other industries. But today's manufacturing techniques are not sustainable. They are energy hungry and inefficient, expensive, and have limited flexibility. The world is asking us to do better. Introducing Pulse Forge tools, a new approach to thermal processes like soldering and curing. Design with more flexibility, manufacture with fewer process steps, reduce energy use, and decarbonize the supply chain. Expand your creativity to new levels. Designers are asking for more. They need to reduce form factors, reduce weight to work on wearables and stretchables, opening new market opportunities for consumers across the world, asking us to do better. If you think sustainability and freedom of design are not possible in electronics manufacturing, think again. Think Pulse Forge.